thank you for attending this talk. It is not easy at this special moment under COVID-19. And this is Jia-Wei Chang from the National Taichung University of Science and Technology in Taiwan. Today, I'd like to share the basic concepts of natural language processing and some personal experience from my works. And this is online of this talk. This talk can divide into two subtopics. The first topic is good for NLP beginners. It is about the foundation of NLP. It includes data processing and traditional and advanced methods for better representation and the popular tasks in NLP fields. The second topic aims to introduce the potential applications in industries from my past works. The first work is about opinion mining by sentiment analysis. The second work develops fault detection and the fault event classification modules by intent classification, and integrated the two modules into an open source chatbot platform. The third work uses text generation to produce advertising copy according to predefined topics, and the more detail of each technique would be guided later. And when it comes to NLP, people usually do not have ideas about how to compute text. Let us start from a simple case. The image is constructed by pixels, and each pixel consists of RGB colors with 256 labels. And this is the basic element of images. And when you knew that, you may have some ideas about image processing with just one photo. However, the basic element of text are more complex because text can be a word consists of some or many words, like a sentence or an article. With other data or pre-trained models, the common methods in NLP are not possible to deal with text with just only one word, one sentence, or one article. Because the computational linguistics is to compute the relations between words, sentence, and the text by the technique of statistics. It means relative work of NLP usually requires a huge corpus. And therefore, the first issue of NLP Foundation is the preprocessing of NLP. It is about how to improve the counting of word and the co-occurrence words better. Compared with image preprocessing, and computational linguistics is not easy to understand. For the second issue, deep learning plays an important role in NLP now, especially deep word embeddings. Deep word embedding is a mainstream methodology to construct the semantic space for the representation of the relationships between words. In the third issue, I'd like to introduce urgency tasks, including sentiment intent analysis, name entity recognition, and text generation. And let's start the preprocessing part. Another big problem in natural language processing is due to various languages in human society. Therefore, the key points of preprocessing are depend on the features of the target language. For example, each word is spread by space in English. It can simply count for each word, but such language has the tense shifting issue. In contrast, the word should be separated by meaningful combination in Chinese. Look at the examples with the same meaning. We can find the different number of tokens for the two languages. And why are these differences so important? And because the foundational concept of computational linguistics is about statics. The small difference in each sentence will become a huge difference in the final results. When more sentences are processed by techniques of statics. In the example sentence, we can find the difference between English and Chinese from the number of tokens and the combinations. Therefore, how to count the word better is the most important issue to NLP. In general, the preprocessing of NLP can be divided into data cleaning and feature selection and data transformation. In the first step, it aims to reduce noise for counting by word segmentation and word streaming. The second step is to remove redundant terms by removing stop words or keeping keyword. The third step is to generalize or normalize data for good better representation. And here is an example. Jack loves eating apples and using many pens to do homework in Chinese. I know that is not a natural sentence, but please take it easy. It is just a sample for the following process. In the word segmentation, the sentence would be separated into many tokens. And they have some meaningful these words, but they will remove by a subword list. In the next step, the single and the pro and the tense shifting problems can be addressed by word streaming. The different forms of nouns and the verbs are transferred into the same term and the combination. It can improve the results for measuring semantic relations. And it's time to discuss why we need better representation. This step is a concept about a document transforms to be a vector in a semantic space. I regard this is the most important step for the downstream test in NLP because it is easy to understand that we can measure the similarity of two words and find similar words by cosine distance measurement if we have a better model of semantic space. I guess you may have a new problem about how to do this stuff now. If yes, it's a good question. You are thinking now, yeah. Let us start from the most traditional way by counting words according to exist or not. We have to document now, and the tables show the turn count of each word. So we have a rough better representation by 1 and 0. With little improvement, we have a better representation by the turn counts than the binary value. Apparently, it is not good enough. It can do better if we use the importance of each word and the term frequency inverse document frequency measure can provide the weights of each word. And we can compute the TF value of word example for two documents. In document 1, it is 0, and it is 0.429 in document 2. Also, we can compute the IDF value of example for the two documents, and it is 0.301 by log, because this were appearing in the document 2 only. Finally, we got the TF-IDF weights of words by multiplying the TF value and the IDF value. So TF-IDF is 0 for the words let, this, and is, which implies that the words are not very informative. Whose mic please turn off. Okay. Okay. If this value is 0, that means it's not very informative as it appears in all documents. The better implementation using TF-IDF seems nice so far. I regard that this step is the most simple part, but it may cost you the most human efforts. That is, you should provide the labels according to the target task, and then input them into the machine learning models for training. How easy it is. So please do your best in preprocessing first. That is the most people can deal with. Otherwise, garbage in and garbage out. And let's go ahead next topic. And I said before, deep work embedding is a mainstream methodology to produce the better representation. And you may say, what? It is TF-IDF not good enough? I can say yes. The previous method produced a very high dimensional sparse matrix. The sparse vector is not good because too many zeros result in efficient and inaccurate when computation. With deep neural networks, we can control the dimension number of vector representation by set up the number of a neural one in the hidden layers. It means the sparse problem can be addressed by projections. On the other hand, DNN can learn the vector representation according to different tasks. In addition, the deep learning model may have a good start by pre-trained models of related tasks. And many approaches prove that this way improves performance by transfer learning. And when it comes to word embedding models, I regard that the following three models are milestones in NLP. The first milestone is word2vector. It is proposed in 2013. The main design has two modes, CBOW and skipgram. They are two-layer networks, including a projection layer and a hidden layer. The second milestone is Elmo. It is proposed in 2018. The most important design is the first bidirectional language models. And Elmo is an LSTM-based model. The The rational language model refers to learn sequence forward and backward at the same time. The third milestone is BERT. It is proposed in 2019. It also used the concept of bidirectional language model and is based on the transformer model. In particular, the BERT is trained by the two tasks of masked language model and the next sentence prediction at the same time. And the more details for three models are provided in 2013. And Mikula served in Google and proposed the word better. This study started a novel direction for better representation by neural networks. The first mode, called CBOW, continuous back of words, is to predict the target word by the former and the following words of the target word. The second mode, called SIGGRAPH, predicts the former and the following words of the target word. The two modes have a same neural network structure, which including a projection layer and the layer. In the projection layer, we can set up the number of neurons for addressing the sparse problems of traditional methods, as I said before. In this study, using the 300 dimensions as the best performance in their class. Therefore, the default value usually use 300 when using word better. In 2018, Peters proposed Elmo by two-layer LSTM and by directional language model. The author thinks that LSTM can learn sequential relations better than ANN. In addition, the forward and the backward LSTM can learn the context more to improve the attention weights in the hidden layer. Therefore, Elmo is the first word-dependent model which depends on its context. I regard that the bidirectional language model inspires the development of the BERT model. BERT is proposed in 2019 by Google AI language team. Currently, the BERT-based models still are the state-of-the-art language models. BERT uses the transformer as its best unit and also is a two-layer transformer with a bidirectional language model. In particular, it is trained by masked language model and the next sentence prediction tasks at the same time. Maybe you have a new question. Why use the transformer instead of LSTM? And Viswani proposed the transformer model in 2017. And this model decides the multi-head attention and implements by ANN architecture. This design can capture the sequential relations more efficiently and can speed up transformer by parallel computing. And transformer-based models have too many parameters. They make people with GPU powers hard to train them from scratch. But in definitely study, the BERT outperforms the Elmo. And from the two works prove that only such huge companies can develop such huge and advanced models and train them from the scratch. Okay, let's introduce some interesting tasks. Uh, Intent classification is significant in chatbot development. It enables chatbots to understand the user request and is key in making the chatbot to be more contextual and offer a personalized conversation experience to users. And opinion mining is finally applied to the voice of the customer uh, materials such as reviews and survey response online and social media for applications that uh, range from marketing to customer service. And the next test is then entity recognition, aka NER. NER classifies named entities mentioned in text into predefined categories such as person names and organizations, locations, and medical codes, and even time expressions, and so on. And NEI is an important technique to enrich semantic information. And we can know the proper nouns of who and where, when, and even what. Therefore, NER not only can help chatbots have better reactions, but also can improve or address many tasks. For example, the NER can be used in bioinformatics. And from the below demo, we can find the gene and the cell keywords from tests by NER. Text generation is the task of generating natural language text. In recent years, it is a rapid group because transformer model. In 2019, Redford from the OpenAI team used the decoder of transformer to generate many amazing articles. Those articles are like human beings' works. In addition, many approaches use GPT-2 to generate lyrics and copies and so on. People who are interested in text generation can find the picture models from the Hugging Face website. You can try the demo by yourself. Is the link. After introduction of popular texts, I'd like to share my personal works. And this is a practical application in opinion mining. We collect the posts and comments of 2018 from a famous forum in Taiwan. We mainly analyze the comments of each post in the gossip division. In 2018, the Taiwan government modified the labor law. Many people dislike this revision, and there are many haters to the Taiwan president and the vice president. And the open mining application can be developed by the comments and posts because people leave a comment with its label, okay, such as tweet, it means like, and she dislike. So we can change the supervised models by those comments with labels. And then the models can recognize the emotion of the comments. In addition, we can define a term is positive or negative by the model. The term can be a brand, a company, a person, or the government, and is very useful in modern society. And the next case is about the development of an anti-fraud chatbot in finance. Mainly we use an open source project called RASA. It provides a complete framework of chatbots. Based on RASA, we develop the fraud detection and the fraud event classification modules by intent analysis. And we define the legal and the illegal and pending confirmation for fraud detection. In addition, we define the subcategories for the 3 modes. For example, the legal organization with the regular event and a legal organization with the regular behavior are belonging to the legal mode. In addition, there are 7 rules for different events under the illegal mode. According to the above predefined rules, we collect the related codes from many sources, including the official website of the National Police Agency, Taiwan. Finally, we successfully developed fraud detection and fraud event classification. And this work is under review by an SCI journal now. And the final case comes from the industry. The requirement is to generate advertising copies according to the predefined topics. We achieve this project using text summarization and text generation. Because we find the GPT-2 can perform better in generating a short text only. For a longer text, the later part of its content usually includes irrelevant content. Therefore, we collect the related articles with predefined topics. In step 1, we use the text rank. It's a text summarization method to extract the key sentence from the articles. By step 2, we use each key sentence to generate a paragraph by GPT-2. In step 3, we select an article as a template, and then matching the similar paragraph to consist of a new copy. Finally, the results can achieve an acceptable standard of human evaluation. Okay, in this talk, I introduced not only the foundation of NLP, but also the popular models and the tasks in NLP. At the end of this talk, I also share my personal works in NLP. With a 30-minute talk, I hope I can help you have some